Imagine a scenario where you're the S4 officer for 2nd Battalion, 6 Marines, supporting the 26th Marine Expeditionary Unit. You're floating in the Mediterranean Sea off the coast of Libya, preparing for an amphibious assault just days from now. Your Marines conduct preventative maintenance checks and services, and when they do, they realize that one of the engines of an LAV required for the assault is down. You mark the vehicle as degraded, and the CO is hounding you to get the parts on order so that the assault can continue. You log into GCSS just as you've done hundreds of times before, and the screen looks like this. Now what? You know you need to get these parts on order so that they can be input and hung into the LAV. The status can go from degraded to up, and most importantly, the CO can get off your back about having a critical piece of equipment on the maintenance production report. If only there was a way to make logging into GCSS Marine Corps a non-event, or at least a non-excruciatingly time suck of an event. Good afternoon. My name is Captain Brittany Snelgrove, and I offer a way to bring the logistics officer and the LAV back to the fight as quickly as possible. The way I'm going to do this is by proposing a new logistical architecture that performs utilizing the technology blockchain. This technology will optimize the Marine at the tactical edge to include a MEU floating in the Mediterranean Sea. With the current Oracle Access Management, memes such as this one are not too far off from the truth. On a serious note, the architecture that I propose will make the authentication process a non-event. Currently, when a user requires access to the web-enabled data resource, this access request is sent all the way back to the Defense Information Systems Agency, or DISA, located in the United States. Once this access request is confirmed, it's sent back to the user, and the user is then able to query the database, pull reports, update, whatever he needs to do. Unfortunately, this process can sometimes take 10, 20, even 30 minutes. Okay, so a while back I mentioned blockchain and how that is going to solve our problems. A lot of you might be thinking when I say blockchain that I'm referring to Bitcoin. And I don't blame you because they were introduced at the same time, but blockchain is the underlying technology of Bitcoin. And blockchain has a lot of other applications to include other cryptocurrencies such as Ethereum and other applications as well. So in this talk, I won't be referring to Bitcoin. I'll be referring to blockchain. Now, in order to understand how blockchain is going to help us with access management to GCSS Marine Corps, we first must understand what a block is. A block is made up of a timestamp, data, which could be financial transactional data, or in our case, authentication data, such as a username and password, a nonce, which is a randomly generated number. And this information is all put into an algorithm which outputs a hash. Each hash builds the next block, and each block builds on the previous block using this hashing function. Okay, so still not making sense, I understand. I'm going to use another example, a logbook. We're all familiar with it, and every unit has one. Each statement written in the logbook is dated and signed using a handwritten signature. Now imagine that our logbook is digitized, and each statement written in the logbook is timestamped and signed using a digital signature. The logbook is utilized in plain sight, and every Marine can see it and all of its previous transactions. However, because each statement is time-stamped, this disallows any changes whatsoever to a statement written in the logbook unless a new transaction is created, canceling the previous transaction. This creates immutability of our logbook. Now imagine that every Marine in the unit has a copy of this logbook, and each statement written in the logbook is made on everyone's copy, and everyone must approve of all transactions made in the logbook. Using this example, a Marine has access to the most convenient logbook instead of having to return to, say, the MEF headquarters or DISA in our case to complete transactions. Picture each approved statement in the logbook creating a block of transactional data, and each block builds on the previous block using the hashing function we spoke about earlier. Our blockchain of logbook entries is decentralized, distributed, and immutable. It is a decentralized ledger of all approved transactions. Now let's relate this back to our original question. How can blockchain help with access management to GCSS Marine Corps? Currently, on a studied MEU, 67% of network time is devoted to this DISA authentication check, and 13.5% of network bandwidth is due to this same fact. We don't have the time or the network availability to allow for this, but yet we still have a requirement for GCSS Marine Corps. With the architecture that I propose, this authentication step can happen locally using blockchain. As seen here, the blockchain is run on these 3 piers located on these 3 ships floating in the ocean. When a client requires access to GCSS, that access request is now sent to the local node running the blockchain. In this scenario, say 2 out of the 3 nodes running the blockchain approve of this user's identity and his request to access the web-enabled service. This access request is granted, and the user is now part of the blockchain, and he is now able to query the database. Relating this back to our logbook example, if a Marine requires access to a secure location, a logbook entry is made, and the Marine is granted access. Every Marine that has a copy of the logbook can now see that said named Marine accessed this specific location at this specific time, and his identity was verified, thus granting him access. Not only does this proposed architecture allow for secured and localized access to GCSS Marine Corps, it has the potential to greatly reduce network overhead. The architecture I propose will allow for protected, distributed operations while eliminating a single point of failure. It will allow for connected distribution of our logistical system. Thank you.